Good morning. Today I will be doing the solution of the exercise for the continuity, that is 5.1. Yesterday I have done some of the question and today I will be doing question number 17. In the question number 17 we have find the relation between a and b so that the function f defined by f of x is equal to ax plus 1. F of x is equal to ax plus 1 if x is less than or equal to 3 and bx plus 3 if x is greater than 3 is continuous at x is equal to 3. Since it is continuous, at x is equal to 3, it means limit of the function f of x tends to 3 plus is equal to limit f of x tends to 3 minus. That means the right hand limit and left hand limit will be same, then only we can say yes, it is continuous. And now it is given that it is already continuous, then find the relation between a and b. Okay, now limit f of x tends to 3 plus, you know that, write limit f of 3 plus h, limit s tends to 0 is equal to limit s tends to 0. 3 plus h more than 3, we will go for the second part of this function, bx plus 3, that is b in bracket 3 plus h plus 3, and that will give you limit s tends to 0, 3b plus bh plus 3. When s tends to 0, it becomes 0, bh becomes 0, and therefore we get here 3b plus 3, right? Now we will find the left hand limit. Limit of f of x tends to 3 minus, and that is equal to limit f of 3 minus h, limit s tends to 0 is equal to limit s tends to 0, 3 minus h. For that we have the function ax plus 1, that is now at a 3 minus h plus 1, and that is equal to 3a minus ax plus 1, and that will give you 3a plus 1. According to the question, 3b plus 3 is equal to 3a plus 1. Therefore, 3b minus 3a is equal to 1 minus 3. 1 minus 3 minus 2, and or I can say that 3b minus 3a plus 2 equal to 0 is the relation between a and b, or I can say 3a minus 3b plus 2 equal to 0 is the relation between a and b, right? Now the next question is question number 18. For what value of lambda the function defined by f of x lambda x square minus 2x and 4x plus 1 is continuous at x is equal to 0? Question number 18. F of x is equal to lambda x square minus 2x for x is less than or equal to 0 and 4x plus 1 if x is greater than 0. It is given that for what value of lambda the given function is continuous at x is equal to 0. Same way we will start. It is given that it is continuous at x is equal to 0. It means left hand limit and right hand limit will be same. Now we find out the limit. Limit of f of x, x tends to 0 minus limit f of 0 minus h, limit s tends to 0 is equal to limit s tends to 0 minus less than 0. For less than 0, this function will have now lambda x square in place of x 0 minus h whole square minus 2 into 0 minus h. This will give you limit x tends to 0 lambda h square minus 2 into 0 plus 2h, and if I put here s equal to 0, the whole function becomes 0. Whatever the value of lambda we have, no problem, but the answer is coming here 0. Second part, limit f of x, x tends to 0 plus is equal to limit f of 0 plus h, limit s tends to 0 is equal to limit s tends to 0, 0 plus s more than 0. You go for the second part of this question, 4 0 plus h plus 1, and that is equal to limit s tends to 0, 4 into 0 plus 4h plus 1, that will have 0 plus 0 plus 1 and is equal to 1. It is now 0 equal to 1, 0 equal to 1. That means if it is continuous at x is equal to 0, it means 0 is equal to 1, which is not at all possible. That means what I am getting now, 0 is equal to 1, which is not possible. Why are it 0 equal to 1? Because it is given that the given function for what value of lambda, the given function is continuous at x equal to 0. When it is continuous at x equal to 0, it means left hand limit and right hand limit would be same. Left hand limit is 0, right hand limit is 1, and now therefore 0 equal to 1, which is not at all possible. That's why what we'll write there is no value of lambda for which f is continuous at x equal to 0. Therefore there is no value of lambda for which the given function f of x is continuous at x equal to 0. This is the first part of the question. Now the second part of the question is, what about the continuity at x is equal to 1? Then we will check the continuity of this function for x is equal to 1. Right? Now limit of f of x tends to 1 minus is equal to limit f of 1 minus h, limit s tends to 0 is equal to limit s tends to 0, 1 minus less than 1. Which function will have? That is greater than 0, it is less than 0, it is less than 1. That means greater than 0, 4x plus 1. This only we can have. Less than 1. I have to check the continuity of this function at x is equal to 1, and for that this is the function 4x plus 1. Now I like here 4 1 minus h plus 1, and that is equal to limit h tends to 0, 4 minus 4h plus 1, that is equal to limit h tends to 0, 4 plus 1, 5 minus 4h is equal to 5. Right? Now 1 minus, that means the left hand limit is 5, right? And now the right hand limit if you have to find out, 1 plus also will have same thing, 5. 1 plus also x greater than 0, we'll apply the same thing, we'll get here 5 only. And f of 1, limit of f of x, and limit f of 1, limit of function f of x, x tends to 1, also we'll get what, 4x plus 1, and that is equal to 4 into 1 plus 1, and that is also 5. This is also 5, this is also 5. It is coming equal. But do you find anywhere lambda in this whole equation? No. That means, therefore, f is continuous at x equal to 1. There is not at all use of lambda over here. That's why, therefore, the given function is continuous at x is equal to 1 for any value of lambda, whatever the lambda may be, but this is not going to impact this part of the given function. That's why the given function is continuous at x equal to 1 for any value of lambda. And now I will do question number 19, right? Question number 19. In the question number 19, it is given that show that the function defined by g of x is equal to x minus greatest integer function x minus x is discontinuous at all integral points. Here x denotes the greatest integer function less than or equal to x, right? We will select for any real number c, right? I will find out now left hand limit and right hand limit. Limit of g of x as x tends to c plus, it is limit of g of c plus h, I will write here c plus h, limit s tends to 0 is equal to limit x tends to 0 c plus h. When I write here c plus h, what I will get now? C plus h minus greatest integer function of c plus h. This will give you limit h tends to 0 c plus h minus c. C plus h is equal to c. C plus h is equal to c. See, you know that 1.1, 1.2, 1.3, its whole value is what? 1. C plus integral part will take the integrator because this is the greatest integer function, right? That's why if it is still 1.02, 1.99, the answer will be 1, right? Similarly, if you have 2 minus something, that means 2 minus 0.9, that is 1.9, then the answer will be 2 minus 1, that means answer will be 1. Here c plus h is very very small, that's why c plus h that is 1 plus 0.1, 1 plus 0.2, the integral part will be 1 only, that's why I have written here c. Then now c and c is cancelled, that is h and s tends to 0, that's the answer is 0, right? Now limit of g of x tends to c minus is equal to limit g of c minus h, limit s tends to 0 is equal to limit h tends to 0 c minus h minus c minus h. This is equal to what now? Limit h tends to 0, c minus h minus. Now c minus h, that is some integral part minus something, 2 minus something, that is 2 minus 1, answer will be 1. 1.3 minus h, very small. 1.3 minus very small number, that means we are going to get 1.3 minus that h, that means what I will get here? C minus 1. So now we will get here c minus 1, and due to this minus it becomes plus 1. Now c and c is cancelled, s tends to 0, what I am getting now? 1. And what we find out? 0 is not equal to 1. That means here 0 is not equal to 1. It implies that LHL is not equal to RHL, or RHL is not equal to LHL, and hence it is a discontinuous function. If you see the graph of greatest integer function, do you remember the graph of greatest integer function? This. We cannot draw the graph of greatest integer functions without lifting up the pen. That's why it is not a continuous function. This is a discontinuous function, right? That means LHL is 1 and RHL is 0. Right? Now, after question number 19th, I will be doing question number 20th. Is the function defined by after that question number 20, is the function defined by f of x is equal to x square minus sin x plus 5. X square minus sin x plus 5 is continuous at x is equal to pi. That means I have to check the continuity of this function at x is equal to pi. Now limit f of x tends to pi plus is equal to limit f of pi plus h, limit s tends to 0, that is equal to limit s tends to 0, pi plus h. What will I write here now? Pi plus h whole square minus sine pi plus h plus 5, that is equal to limit s tends to 0. This will give you pi square sine pi plus h. Sine pi plus h will be what? Sine h. Sine 180 plus theta. Sine theta plus 5. That means answer, what I am getting, sine h, that means sine 0, and sine 0 is 0. That's why answer is pi square plus 5. Right? Now limit f of x tends to pi minus RHL LHL is equal to limit f of pi minus h, limit s tends to 0 is equal to limit s tends to 0, f of pi minus h, what will I get? Pi minus h whole square minus sine pi minus h plus 5, and that is equal to limit s tends to 0, pi minus h whole square. Can I write simply pi square? Right? Because both the terms pi square plus h square minus 2 pi h will have h, and therefore h tends to 0, it becomes 0. Simply pi square is alright. Now here minus sine pi minus h. Sine pi minus h will be also how much? Sine h only. Right? Now sine h in the second quadrant. In the second quadrant, sign is positive. Now plus 5. Now s tends to 0. Therefore sine 0 will be 0. Therefore we will get here pi square minus 0 plus 5 is equal to pi square plus 5. This is pi square plus 5. This is also pi square plus 5. And if I put the value of x is equal to pi, f of pi will be also how much? Pi square minus sine pi plus phi. Sine pi, that is sine 180, that is 0, right? And therefore I'll get pi square plus phi. And therefore limit f of x tends to pi plus is equal to limit f of x tends to pi minus is equal to f of pi. All the three values are same, and hence it is a continuous function at x is equal to pi. Right, this was question number 20th. Now in question number 21, right, in the question number 21 we have the given question is discuss the continuity of the following functions. F of x is equal to sin x plus cos x. F of x, discuss the continuity of the function a. F of x is equal to sin x plus cos x. Let us assume here let g of x is equal to sin x and h of x is equal to cos. So that means I am taking this as two different functions. I can solve these questions without finding out their LHS and RHS also, because just I made you to write one line that all the trigonometric functions are continuous function. That's why of course sin x and cos x are the continuous functions, and there, since this function is gx, this is h of x, and we know that when two functions are continuous, then their composition or their addition is also continuous. That already I made it to write it, and we know. But anyhow, I'll show you. Yes, g of x, that is sin x, is also a continuous function, and h of x is equal to cos x is also a continuous function, and then we will go for the result. Now first of all I will check it for g of x is equal to sin x. So now limit g of x tends to c plus. See, there is no any value, that's why I will go for any particular value, and that is c. Therefore now limit g of c plus h, limit h tends to 0, is equal to limit h tends to 0 gc plus h, gx is equal to sin x, I've already get sin c plus h, and limit h tends to 0 sin c plus h, sin a plus b, sin c into cos h plus cos c into sin h. Now h tends to 0, therefore what? Sin c into cos 0, sin c into cos 0 plus cos c into sin 0. Now this becomes what? Sin c into cos 0, sin c into 1, sin c, cos c into 0, sin 0 is 0, therefore it becomes 0. Therefore can I write simply that is equal to sin c, right? Similarly, if I find it now, limit of g of x tends to c minus, we have now limit g of c minus h, limit s tends to 0 is equal to limit s tends to 0 sin g of c minus h, g of x equal to sin x, g of c minus h, sin c minus h. Now expand it, limit s tends to 0 sin a minus b, sin a minus b is equal to what? Sin a into cos b minus cos c into sin a. Now again s tends to 0, what will get? Limit h tends to 0 sin c into cos 0 minus cos c into sin 0. Again here, being sin 0 0, 0 into sin c will become 0, and sin c into cos 0 is 1, that's why sin c. Now that is equal to sin c minus 0, what I will get now? Sin c. Therefore, RHL and LHL both are same. RHL is equal to LHL, and the value of GC is also sin C, right? G of C is also sin C. Therefore it is a continuous function. And similarly, I will check it for h of x, and that is equal to cos x, right? Now I will check it for h of x is equal to cos x, same thing, right? Now I will check it for limit h of x tends to c plus is equal to limit h of c plus h limit h tends to 0. Right? This h is the function. Don't get confused this h. This is equal to what? Limit h tends to 0. Sc plus s equal to cos c plus s, and cos a into b is what? Limit s tends to 0 cos c into cos h minus sin c into sin h. Now limit s tends to 0 cos c into cos s, cos 0 minus sin c into sin 0. It becomes 0, cos 0 1, therefore I am here getting that is it cos c. Now I will find out limit h of x as x tends to c minus, that is equal to limit h of c minus h, limit h tends to 0 is equal to limit h tends to 0 c minus h, that is what? Cos c minus h, cos a minus b, cos c into cos h plus sin c into sin h, and limit h tends to 0, and that is what? Cos c into cos 0 plus sin c into sin 0. This is 0, sin c also becomes 0, 0 into sin c 0, cos 0 1, and therefore I will get what? Cos c. So now here what? Again LHL is equal to RHL, and therefore it is a continuous function. Now what we have done? We have proved that the given function f of x is the combination of two functions g of x and h of x. G of x and h of x. And we have read, I made you to write one line, yes, if f is a continuous function, g is a continuous function, then f plus g is also a continuous function. Therefore, now I will write the final statement for this question. Now, as we know that if g and h are two continuous function, then g plus h is also a continuous function. This is the statement, right? And f of x here, f of x is equal to g of x plus h of x is equal to sin x plus cos x, and hence f of x is also a continuous function at x is equal to c, or simply you can write at is a continuous function. In place of c I can take any number, that is alright. Similarly, we know that when f and g are a continuous function, then f minus g is also a continuous function, f into g is also a continuous function, and f divided by g is also continuous functions, provided g is not equal to 0. Right? That's why I think now you can do it. Now question number 23. Question number 23. F of x is equal to sin x upon x if x is less than 0, sin x upon x provided x is less than 0, and is x plus 1 if x is greater than equal to 0. And we have to check that the point of discontinuity for the given function f at 0. I will check it for x equal to 0. Right? Now, at x equal to 0, limit f of x, x tends to 0 plus, that is RHL, right hand limit, that is equal to limit f of 0 plus h, limit s tends to 0 is equal to limit s tends to 0, 0 plus h, x greater than or equal to 0, x plus 1. That is now what? 0 plus h plus 1, and that is equal to 1. Right? Now LHL, limit f of x, x tends to 0 minus, limit f of 0 minus h, limit s tends to 0 is equal to limit s tends to 0, 0 minus less than 0, the first function sin x by x, what I'll write? Sin 0 minus h upon 0 minus h. That will give you limit s tends to 0, sin 0 minus h, sin minus h upon minus h is equal to limit s tends to 0, sin minus theta is what? Minus sin theta. So we can write now minus sin h upon minus h, minus minus cancel. Now this will give you limit s tends to 0, sin h and by h. And you know that limit sin of x upon x, x tends to 0 is gives you 1. The value or the formula which we use for the limit. Limit of sin x upon x, x tends to 0 equal to 1. Here limit s tends to 0, sin h by s is equal to 1. This is also 1, this is also 1. If I will go for f0, so now here f of 0 is equal to what? 0 plus 1. F of 0, f of x is equal to x plus 1, and therefore f of 0 is also 0 plus 1 equal to 0. That is what? LHL is equal to RSL, and hence it is a continuous function at x equal to 0. That means there is no point of discontinuity, or what I can say that hence f is continuous at all points of the real number line and having no point of discontinuity. Right? Now the next question is question number 25. Question number 25. Then 25. Question number 25. Question number 25 is Examine the continuity of the function f defined by f of x is equal to sin x minus cos x if x is not equal to 0, and the second part of the given function is minus 1 if x equal to 0, right? And we have to check the continuity of this function, right? That means, of course, I will check the continuity of the function at x equal to 0. At x equal to 0, LHL limit f of x tends to 0 plus is equal to limit f of 0 plus h limit s tends to 0, and that is equal to what? Sin x minus cos x, because 0 plus s is not equal to 0, no? Therefore, now I write a limit s tends to 0 sin 0 plus h minus cos 0 plus h, and that is equal to limit s tends to 0 sin h minus cos h. Now s tends to 0, therefore now sin 0 minus cos 0, and cos 0 is how much? This is 0 minus 1 is equal to minus 1. Sin 0 is 0, right? Now RHL limit f of x tends to 0 minus, we have what? Limit f of 0 minus h, limit s tends to 0. Again I will get limit s tends to 0 sin 0 minus h minus cos 0 minus h, that is now limit s tends to 0 sin 0 minus h sin minus h minus cos minus theta which I can write now limit s tends to 0 sin minus theta is minus sin theta, and cos minus theta is positive cos theta, that's why it will remain simply cos h. Now put value 0, now minus 0 minus 1, and that equal to how much? Minus 1 minus 1. If I go for f of 0 is already given what? Minus 1, and therefore f of 0 is already minus 1, and therefore what we find that LHL is equal to RHL, and therefore it is continuous at x equal to 0, right? That means there is no point of discontinuity for this again given function. Now from question number 26 to 29, from 26 to 30, it is given that the given function is continuous, and when the function is continuous you have to find the value of the missing value, whether it is k or a or b or c, something like that. Here I will be doing two questions, question number 27 and 30, right? Question number 27 and 30 I will be doing, right? The question number 27 is f of x is equal to kx square. 27 and 30, two questions I will do. From 26 to 29, 26, 27, 28, 29, it is given that the given function is continuous at a particular value, particular point, then find the missing. In the question number 26, you are asked to find the value of k. In the 27 also k, 28 and 29 you are asked to find the value of k. In the question number 27 we have f of x is equal to kx square. F of x is equal to kx square provided x is not equal to pi by 2. kx square provided x is less than equal to 2. X is less than equal to 2, and the second part of the given function is 3. 3 when x is greater than 2. Okay. Now at x is equal to 2, limit of f of x, x tends to 2 plus. Now limit when x is 2 plus, that means what? X is greater than 2. Simply can write now directly 3, nothing to do, is equal to 3. Now limit f of x, x tends to 2 minus, is equal to limit x tends to 0, f of 2 minus h is equal to limit s to 0, f of 2 minus h less than equal to 2. That means k and 2 minus h whole square is equal to limit s tends to 0. Simply can write now k 2 minus a square b square minus 4h. If I don't write the whole square, then also simply will have 2 square 4, because s tends to 0, I will get 4k. But anyhow, now if I put the value h equal to 0, 0, 0, simply I get here 4k. Now since the given function is continuous at x is equal to 2, therefore the value of 4k and the value of 3 should be same. Therefore now I write, since it is a continuous function, hence 4k is equal to 3, and imply that k is equal to 3 by 4. Similarly, the question number 26 and 28 and 29 you can find out, right? Now I will be doing the last question of this exercise, that is question number 30th. The question number 30th has been asked in the board examinations many times. Question number 30th. F of x is equal to 5 when x is less than equal to 2. 5 x is less than equal to 2. Second part is ax plus b. Ax plus b provided x is less than equal to 10 and greater than equal to 10. Less than 10 and greater than 2. Right, and the third part of the is 21 when x is greater than equal to 10, right? That means for the question is find the value of a and b such that the given function defined by x is a continuous function. Now here there are 2 points, less than equal to 2 and 2, x is greater than 2 is there, x is less than equal to 2 is there. That means we can check it the continuity of this function at x is equal to 2 also, right? And x is less than 10 and greater than equal to 10 is also given. Therefore, we can check the continuity of this function at x equal to 10 also. So first of all, I will check for at x equal to 2. So now limit f of x, x tends to 2 plus, right? That means when x is greater than equal to 2. So now what I will get here, limit f of 2 plus h, s tends to 0 is equal to limit s tends to 0, 2 plus s is greater than 2, which function? This value, ax plus b. That means a, in place of x we have 2 plus h plus b, and that will give you 2a plus b, right? Now, if I go for 2 minus or add 2, same thing. Less than equal to 2 or 2 minus, same thing. That means, and also we have, you know that f of 2, that means at 2 the value is 5. Therefore, since it is a continuous function, therefore we have 2a plus b is equal to 5, and this is the first equation. right? Now I'll check at x is equal to 10. X is equal to 10, right? At x equal to 10, I'll check now limit f of x tends to 10 minus. Then I'll get what? Limit f of 10 minus h, limit s tends to 0 is equal to limit h tends to 0, 10 minus h, which one? X less than 10, again the same function, a 10 minus h plus b, and that will give you what? 10a plus b, because ah s tends to 0 becomes 0. So now 10a plus b, right? Now f of 10 is equal to what? Tell me. F of greater than or equal to 10 is how much? 21. It implies that what? 10a plus b is equal to 21. This is the second equation. Got my point or not? 2a plus b is equal to 5. 2a plus b is equal to 5, right? One equation we have got. 2a plus b is equal to 5, and the second equation is 10a plus b is equal to 21. Now solve these two equations to get the value of a and b, right? Now from first and equation second, 2a plus b is equal to 5, and second is 10a plus b 21. If I subtract it, minus, this part is cancelled. 2a minus 10a minus 8a minus 16, it implies that a is equal to 2, right? And put the value of a, put a is equal to 2 in equation 1. 2a plus b is equal to 5. That means 2 into 2 plus b is equal to 5. It implies that b is equal to 5 minus 4 is equal to 1. And therefore, a is equal to 2 and b is equal to 1. A is equal to 2 and b is equal to 1. A is going to give the answer for this given equation, and so that this given function is continuous if the value of a is 2 and b is 1, right? This was the whole regarding the continuity. Now this part is complete, the continuity. Now we have to do a lot. Well, I'll going for the next exercise, that is differentiability. That's why tomorrow for the next lesson I am going to discuss the differentiability of a given function. And I hope you all should be ready, and please do a lot of practice, my dear, because unless you won't do, you won't get it. Please do it at your home. Do well and take care of yourself. Thank you very much. Have a nice day.